Hello, good day to you all. How has been our day? I hope you are fine today. Today we want to look at indices. This is mathematics class. We want to look at indices. If you see indices, how are we going to know that it is an indices? Now this is indices. This is how indices look like. When you have something like y raised to power p, this is an indices. Because y is an whole number, the index number is p. When you have an whole number and index number combined together, that equation is called an indices equation. Now that is how to recognize indices as a topic. Now indices is a very simple topic in mathematics, but the laws are the things that we need to follow. In as much we want to understand how to solve indices equations, then the laws are very important for us, because if there's no law, there's no sin. But if there are laws, then there will be sin for people that break the law. Now that is why these laws are very important. If we understand all these laws, believe you in me, there is no problem in indices that we will not be able to solve. Now, the first law states that when you have x raised to power a times x raised to power b, x is a whole number here. A is an index number. Also, x is a whole number. B is an index number. Now, if you look at it very well, you discover that the whole number look alike. Once the whole number look alike, just pick only one of them to represent the two. I believe you are getting it. Then you now pick the index number together, a then b. But something will be in between a and b. What are we going to put there? Is it going to be plus or minus? I mean, is it going to be addition or subtraction? It's going to be addition, because of the fact that what is separating the whole number here is times. Just take note, anytime you are working on indices and you discover that the whole numbers are separated with multiplication sign, then you are going to treat the index number with what? With addition. But on the other hand, if the whole numbers are separated with division, then you are going to treat the index numbers with what? With subtraction. Take note of that. That is very important. So therefore, x raised to power b times x raised to power b, x raised to power a times x raised to power b give us x raised to power a plus b. I believe that is clear. Let us apply that. Let us put it into practice. Like we have something like 2 raised to power 2 times 2 raised to power 3. So these two and these two are whole numbers and they are uniform. Pick only one of them. The index number, put them together, 2, then 3. What are you putting in between 2 and 3? You are going to put plus. Because of the fact that multiplication is separating the whole numbers, the uniform whole numbers. So that is why we are having 2 raised to power 2 plus 3 is what? Is 5. And what is 2 raised to power 5? 2 times 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. The final answer is going to be what? 32. Therefore, 2 raised to power 2 times 2 raised to power 3 give us 32. It is very simple. So I believe that law 1 is clear to us. Let us go to law 2, the second law. X raised to power a divided by x raised to power b. It gives us x raised to power, since the whole numbers are uniform, that will be the first target anytime you are working on indices. Look at the whole numbers. Are the whole numbers uniform? Once they are uniform, just simply pick one. No matter, regardless of the numbers of the whole number, whether they are 3, whether they are 4, whether they are 20, just pick only one to represent all of them, since they are what? They are uniform. So since I have x and x here, the whole numbers are uniform, I pick only one to represent the two. But the index number, I put a. The another index number, I put b. But something will be at the in between a and b. It's going to be subtraction sign, minus. Why is it so? Because of the fact that the whole number are separated with what? With division sign. So when the whole numbers are separated with division sign, you are going to treat the index number with minus. But when the whole numbers are separated with multiplication sign, then you are going to treat the index number with what? Addition sign. That is a plus sign. So to apply the second law, this is the application of the first law. The application of the second law, assuming we have 3 raised to power 4 divided by 3 raised to power 2. What are we going to get? 3 raised to power 4 divided by 3 raised to power 2. 3 here is a whole number, another 3 here is a whole number. They are uniform whole number. Take 1 to represent the two of them. Then you now deal with the index numbers. 4 and what? 4 and 2. Something is in between 4 and 2. What is that? It is minus. The subtraction sign. Why is it so? Because of the fact that the whole numbers are separated with what? With division sign. Don't forget. And what is 3 raised to power? What is 4 minus 2? 4 minus 2 is what? Is 2. That is 3 raised to power 2. And what is 3 raised to power 2? Is 3 times 3. And what is 3 times 3? That gives us 9. The answer to the application of the second law, which is 3 raised to power 4 divided by 3 raised to power 2, give us what? Give us 9. I believe the answer is clear to us. Then we go to the next one, the law number 3. X raised to power minus a. This x raised to power minus a simply gives us 1 divided by x raised to power a. That is law number 3. X raised to power minus a gives us 1 divided by x raised to power a. Let us look at the application of the third one. If you have something like you have 2 raised to power minus 3. 2 raised to power what? Minus 3. This one will give us 1 divided by 2 raised to power 3. 1 divided by every other thing. Anytime you are having in indices, you have something raised to power something. Maybe you have p raised to power minus k. It's going to be 1 divided by, you write everything again as denominator, but without minus this time around. That is 1 divided by p raised to power k. I believe we are getting it. So that's why we are having 2 raised to power minus 3 giving us 1 divided by 2 raised to power 3. And that gives us 1 divided by 2 raised to power 3 is 2 times 2 times 2 times 2. 2 times 2 times 2. And that will give us 1 divided by 2 times 2, 4, 4 times 2, 8. 1 divided by 8. That is the answer to that one. I believe that one is clear to us. Is it clear? The third application to the third law. Then the fourth law. Let's look at the fourth law. When you have x raised to power a divided by b, it gives us b here out, then you have a out. Take note of the law. The law is very important. Once we have the law, once we understand the laws, then we don't have problem to solve equations that have indices. Now, the application is this. Assuming we have something like this, we have simplify 8 raised to power 2 over 3. 8 raised to power 2 over 3. This one will give us, just look at it. 8 is here, 3 is here, then 2 is out. You can just relate x inside, 8 inside, a outside, 2 outside, then b inside here, 3 inside here. So what is cube root of 8? Cube root of 8 is nothing but 2. You have 2 raised to power 2. And what is 2 raised to power 2? That is 2 square. 2 square means 2 times 2, and which gives us 4. The final answer to this question, 8 raised to power 2 over 3 is what? The answer is what? 4. I believe it is clear to us. Then we go to the last law. The last law is x raised to power 0. Anytime you are working in mathematics and you see anything raised to power 0, the final answer simply equals to 1. The final answer is what? It's 1. Even if you have 1 million raised to power 0, the final answer still remains 1. I believe that is clear to us. That is the application of the last law, law number 5. So these are the laws we need to just take note in mathematics anytime we are solving indices questions. So in our subsequent classes, we are still going to be applying the laws. We are going to be bringing questions, and we are going to be solving the questions with the laws we have stated. There's no other law to solving indices apart from these laws. Thank you for watching. God bless you. See you next time. Bye bye.